Hello everyone. I'll have to do some different setup here. Um, so we will just be hanging out until this thing really starts. I'll talk more about how this thing is going to work. Let's see, I'm also live on Twitch, but I need to swap the chat since this is primarily a YouTube feature. Uh, let's see. Let's see. I'm just gonna mess around with that. Copy that. Add. Let's see. Maybe we don't want. Let's see. Pop up. Maybe we want. Well, can't I change the format of the YouTube chat here? Well, I can. It seems. Okay. And let's do like this and maybe, whoops, adjust the height. since we're probably going to use yeah, this is really unprofessional. I'm not let's see. Oops. Change YouTube chat from top to live chat browser. Let's see. For some reason, it doesn't seem like I can control. Am I able to change some of this stuff here? Luckily, no one tuned in yet, so and we're not recording anything in terms of the guide. I'm also having some coffee here. So far we're not in a hurry. But I would like to be able to change. Uh, let's see. Maybe if I change it here, does it then? No. Can I set timestamps? Well, maybe if well, it won't allow me to. Uh, can I? Oh, I can interact here. Okay. Okay. Okay, there we go. Let me just send a test message here. I can't swipe or anything. Uh, well, okay. I think we are maybe done setting this up. Mm, I know it's probably a bit early or a bit late for some people, but I had to do a bit of what do you call it? Up scheduling, or yeah, something like moving the time for this project a bit earlier than originally planned. Um, yeah, since I have to do some different stuff today. I'll be doing simultaneous recordings in terms of uploading a video series to the YouTube channel. Let me see. All right, I'll do a generalized introduction. I just need to Get myself sorted in terms of having the Twitch chat available. Um, uh, and I need to figure out a way to be able to see the YouTube stuff as well. Uh, okay. I could do the Twitch thingy as an overlay even. Yeah, maybe I just check in with Twitch from time to time because this is primarily a YouTube feature. I'm just also streaming it on Twitch for good measure. Maybe we should set up something like an outline of sorts. Maybe we can do that in OBS. We need to add a text. Let's see. Uh, uh, let's see. Yeah, we have been fiddling around with the stream setup here. Let's see. Uh, Okay, let's see. Wow, this text is big. Let's scale it down. I mean, that is so big. Hopefully it doesn't annoy anyone up here. Maybe. No, that looks terrible. Okay. Maybe we maybe we are set. This took longer than expected, but well, things do um, turn out that way whenever you haven't done things like that before. Yeah, okay. Let's see. Okay, I think I'll add a stamp to the stream here because we're about to begin. Oh well, doesn't do anything. Let's see, maybe if I use my other platform here. Okay, this way I could actually do maybe okay, I guess I was a bit fast on that one. Let's see. Can I control? Oh, well, doesn't matter. I think I'll do messages. Can I do something in terms of this video playback is not great. Oh, I guess I promised starting the stream here. Okay. This allows me to see the chat of both Twitch and let's see. So this is analytics. Yeah, I'm sorry, I'll get started soon enough. Can I access? Well, there's no interface for this. There is a live now function here. Okay. I think we will run with this setup. I'll have one place to access the whole thing here. And I don't think I need to monitor the YouTube part of things. Okay. Okay. Let's. But I would like to be able to disable. Maybe I just do like this. And I'll do another test here because I need to check that everything is working on. Okay, so this actually works. I'll have a combined panel to see. Yeah, we're about to start a total beginner tutorial um, uh, in a few minutes. I just need to make sure the stream is set up correctly. No problem. It was Mr. Yes who asked for it during a previous stream, so time to live up to that promise. Let me see. I just need to make sure that the stream is working as I intend to. And then we will get going. Okay. Can I change? Yeah. Okay. I think I have everything set up. Uh, can I do? Well, I don't need to do that. Okay. I think I have my chat set up. So the plan for this project is to help you create a application that runs on DirectX 12. Um, I, I will be recording videos that I will be uploading to the YouTube channel, and I'll um, kind of like let the live audience know when I start the recording and when I have ended the recording. Um, I think I'll do it in a way where uh, we will do some breaks along the way in terms of um, um, answering questions and doing different discussions. The stream is primarily focused on YouTube, which means that um, I have only displayed the YouTube chat and it's in subscriber mode. I'll try to answer the questions at specific intervals during the stream. The stream might be um, subdivided into different parts, and we will see how far we get today. Yeah, I think that is it. Maybe there's something I forgot to say, but we will probably just get there. I'll start the recording for the first part of the video tutorial series. Yeah, so we should be recording now. So if you're watching this in the future, welcome to this tutorial series, which is recorded during a live stream session that is available in the archive here on YouTube. Hello, welcome. I will not be interacting a lot with chat, but we will do different questions at specific breakpoints. I'll include this at the end of each part of the YouTube videos. Yeah. This is not a C++ tutorial, but a tutorial focused on DirectX 12 and getting set up with that. So yeah, welcome to everyone who joined the stream so far. I will try to focus on getting the different stuff done. So yeah, I'll let you know when the recording for the YouTube video series um, is done, and we will do a more stream-like interaction after that point. All right. But the first step is that we need to set up a project. And we will use our good old Visual Studio here. We will create a new project and we will do it in a C++. And um, and I'll try not to get too distracted um, on the way. So we want to set up a project with a precompiled header. Sometimes we can do that precompiled PCH. Usually Visual Studio has a would let's see, all languages, C++, hello world. Okay, well, we will probably just do it without PCH files, since that's an optimization for a larger project that you could always implement yourself. So, well, anyway, we will do an empty project. And we will have to make a project for it. Okay. Everything will be available in at GitHub afterwards. So if you miss anything, don't worry. We will do a DirectX framework here, which we will select. And we will call our project here the engine. So we will create a separate project for that. And we will add another project. Let's see, can I add a project? Isn't there a project only? Isn't there a fast way? Anyway, well, the fastest way will be to do something like this. We will do another project here that will be our added to our solution. We will do the application layer here, and it will be stored, as you can see, in the same source directory. I've just changed the viewer here to regular file mode. I'll do it for each project. We will do some setup here. Whoops, I accidentally opened the help menu. That doesn't do anything good. So we will have to set up our projects here. First, we're gonna manage our configurations. We will only do x64 platforms, meaning that we will do only support of 64-bit platforms. Let's see, we have we also need to change the platform here. This is just some basic tidying here. Okay, great. Let's do the same thing for this in case it didn't register. It did. It was for the whole solution. Okay. We would want our application to be a sort of DLL. Not a sort of, it will be a DLL, a dynamically linked library. I won't explain too much about that. And we will have our application here be an actual application, and we will set up references to our engine. We will also set this as our startup project. Wait a minute, or isn't that the start? Maybe it is the startup project. Set a startup project. There we go. So right now, yeah. Does it compile to a? Yeah, okay, it can't find the lib, which is fine because we haven't set up anything yet. But we would like an output directory and we will remove our platform here. We will remap our intermediate directory as well into the same maybe we just do like this. So this means that we will compile everything in terms of relative to our solution directory. Maybe we do something like binary, and maybe we do no, let's do it like this. So we will output this into a sub root folder called binary. This is important because when you compile a DLL, you can't find it if you don't set up this properly. Let's see, that was the application. That was the there we go. And let's do the intermediate. I think I did ITM right. Okay, I think that was the same. Yeah. Okay, let's try compiling some stuff here. We need to create a source folder and also create a source folder here. These, remember, if you have filter mode on, you will create filters instead. Let's do a CPP file, which we will call main. And we will do our classic int main function here. And all right, the application can't seem to find our lib file. Let's see, we need to do some includes. It's probably because we don't create anything. Let's just do a new temporary class that we would like to include here. Let's do a public int test. And let's see what our system creates as our intermediates. We will probably have to include our projects, or rather our DLL. Let's see. Oh, okay. So this is the problem. We have some problems in terms of setup here. We actually have to set up our solution here. Application. I think configuration manager. I've actually not done this before. Instead of redoing the whole project, let me see. It's like we end up in a situation. Am I doing this wrong? Solution directory. The solution directory might be path wrong. Let's see, change solution directory, Visual Studio. Save as solution filter. No, that wasn't. Click on file. Save as, maybe. Where did he save my project solution? Is it up here? Oh, this is just annoying. Well, messing around with Visual Studio is not my strong suit. I'm in Solution Explorer. Select the solution. I've done that. File, save, engine solution as. Okay, there we go. DirectX framework. There we go. And do we end up in a situation where, let's see, I think we might have fixed it. Okay, as you can see now, we do get a binary um, uh, and an intermediate folder here. Let's just clean everything. Let's see. Our application is fine. We don't need this folder. Intermediate is fine. We don't need this. We don't need this. We don't need these. We don't need this. Okay. All right. Next, we need to add a include directory to our project here because we cannot link to anything in particular. If we try to build it, it will succeed, but it can't find the .lib. Which we will set up shortly. Let me see. I just want to see what it does compile. So the binary release engine.dll does actually get compiled. The application doesn't get compiled because it can't find the includes. So that's fine. We need to set up our project here in terms of including, excuse me, our relevant files. So we have set up our output directories. We will do our include stuff. Let's see. We will do it under the C++ include. We will do a solution directory, and we will path to our engine, and we will add the source directory for all current configurations. Let's see. So now we can actually link to our file here. Let me see. I'm missing some setup here. Because I haven't done this a lot of times, so we need to set up the linker, I think. I promise it will get better whenever I have to stop fiddling around with the Visual Studio stuff. As I've mentioned, it's not my strong suit. Is it the way I set up this project? It's supposed to compile as a it wants to find a lib file, which I do not intend to include. Let me see. I think I'll have to look up intermediate directory. Does it need to be maybe specific for the project here? Oh, whoops. We will at least do that project because could not open input file bin release. Name. And we will do the same thing here. Yeah, I'll just Google it. Visual Studio Linker DLL lib. No. Maybe we have to do external dependencies. Well, this is awkward. Visual Studio is always getting the best of me. Let me just look at my old project here. How did I really set up things? The application here looks into the solution directory. Do I need to do the additional include directories? Oh, maybe it's in the preprocessor setup. Yeah, I think I remember that this needs to be different. Yeah, because this is a console project. That's the mistake. That's the mistake, I think. Because it right now it defines the output file as a console, and it probably expects a lib whenever we compile into a console. Let's see, preprocessor, Visual Studio, DLL. Uh, DLL. What is user DLL? Let me see. My old project here uses the USR DLL instead. Okay, anyway, I think we will just do DLL here. Let's do it for all configuration. Oh, it has different options, of course, because of the preprocessor macros. We would also like it only to compile on Windows. Exports Visual Studio preprocessor. Oh, there we go. Thanks for everyone tuning into the chat. Yeah, the problem arose because I chose two console applications and swapped them. You won't run into the same problem if we do it like that. We can also just do something simple like this. Remove the engine and add a new project here. This should have been done way earlier. We simply choose a DLL instead, and we will create, we will add it to the solution here. And there we go. The application here will have references to the engine. We will also swap to our view here and add a source. And this actually comes with a PCH file. Let's remove these. And let's see if everything compiles now. And of course, we need to set up this. As you can see here, it adds the preprocessor macros now. The output directory, of course, needs to be mirrored to this. There we go. And the oh, wait a minute, we're only doing it for one setup. Okay, we will be done in a second, I think, in terms of doing this stuff here. Let's just do the bin setup here. Okay. should be the same, right? Yeah, bin. Okay. Let's see, we don't need this. And we have our PCH stuff, which is great. And we still get the same error. So that didn't solve anything. Visual Studio. Oh, okay. Yeah. That's because we haven't set up the preprocessor macro yet. Never mind. My mistake. So inside our um, engine project. Okay, things will get moving now, I think. Let's see. We will set up a macro here that will do if the preprocessor macro. Let's do YouTube build DLL. If that is set, we do something. Otherwise, we do something else. And yeah, so we define our YouTube API to be a export DLL. Thank you to Stack Overflow for sorting this out. Try and improve the method, and we will do our import otherwise. And we will, of course, have to set this macro here. Let's do a engine minimum header file, because we will always need that. External dependencies, references, well, it doesn't matter. And in our PCH file, we will always include the engine minimum. We will add the macro to our preprocess statement for our DLL. Engine exports, I'm unsure what that preprocess statement means. Anyway, we will do our own macro here, and we will save that, and we will save that. And we will do a class here that will do our YouTube API. It should be, there we go. It's because it's not in the right folder. Oh, maybe it's pre-set up macro then. Thank you very much for clarifying that. Okay. Well, why does it want to link? Build order. Okay. We still have the same problem. Maybe I need to include our engine. Okay, I haven't added the include directory, have I? Additional engine source. Well, we should have. Let's do temp class. For some reason it can't find it. Solution is our directory not set up correctly? Let's see. Oh, now that is interesting, right? Now that is interesting. Okay, we're in a lot of trouble here. Let's just move this and retarget everything. Well, well, well. It turned out that this tutorial series ran into a Visual Studio problem. Yeah. Retarget. Not retarget projects. Unload project. Remove it. Add a project here instead. Existing project. Engine project. Let's set it to, whoops. And let's try. Let's remove these. Let's check our includes here. Solution directory, engine. Let's rebuild solution. Does it not accept my, let's clean all of this. engine source, solution directory, solution directory. Let's see. We aren't getting anything in terms of. Oh my God. Okay. I think I'll simply start over since it's faster than all this retargeting. I'll of course not upload this to YouTube. Yeah. Visual Studio. Okay, create a new project. We will do first the DLL project here. Yeah. Okay, I'll just have to restart the recording here. Sorry. All right, this is take 2 in terms of the tutorial series on setting up a, or rather doing a application in DirectX 12. It's not a C++ tutorial. It's focused on the DirectX 12 API. Yeah, on the live stream, I ran into Visual Studio problems, so this is take 2. Yeah, I'll do questions from the chat at the end of parts of this video series. If I left anything out, you can always watch the original live stream in the archive. Okay, I'll set up the Visual Studio project here. Let's clean everything up in here. Yeah, I'll try one more time to do it fast. And then if it doesn't work, we will do something else. The solution will be DirectX 12 framework. There we go. Path seems to check out. We don't need this. This will export as an DLL. We will set up our configurations shortly. Configuration manager, didn't I have one? Okay, anyway, we will do it like this. We will remove the platform and we will remove the Win32 configuration platform, or rather platform, and we will create a source directory here. And we will delete these and we will move the PCH files. All right. We will add a project to this, which will be an empty project. And we will do the application here. We will add dependencies to our engine. Now that looks right. We will create a source folder and we will set this as our startup project. Oh my God. Hopefully we will. We will do our main function here. Whoops. Why does it? Oh, it maybe. At least it did it all in the same solution directory. Visual Studio doesn't create lib file for DLL, does not generate it. Yeah. Okay, we still do the export. Yeah, I know, buddy, but I've done DLLs in my other project, so I'm going to implement it the same way, and let's do the macro that it already supplied for us, engine exports. So we don't need to do it else, and we will do define YouTube API. Yeah, sure thing. Let's see. Let's YouTube API. DLL import. And we include this in our PCH file. The engine minimum. Okay. And we of course need to build a, or rather add a solution directory /engine/source as our include path for our application here. Let's do a temp class, which we will move to here. Yeah, hopefully we're done setting up shortly. Let's see, YouTube API, because this is really not interesting. Public int test. Okay, and let's see, can we now include? Yeah, we can include our temporary class here. Let's see. I made a mistake somewhere. Let me see. Okay, at least we're now not getting the whole. Oh, I swapped these. There we go. And we need to. Well, it should use the precompiled header here. Precompiled headers use, and we have set up precompiled headers here. Create. Well, okay, we will include our engine minimum here, and we're going. All right. Yeah. For some reason, it wants us to include the thing, even though it's part of a precompiled header. All right. Finally, we got set up. So the last thing we need to do is make sure our output directories work correctly. Let's see. Yeah, thank you to Malformed Era to point out that the right fix was the export and import. It was the same thing that Stack Overflow mentioned several times. All right, let's make sure that our output directory is correct. We combine it with our platform, our configuration, our intermediate stuff. Well, that should be fine. Let's simply check out that every configuration works. And let's see if our application here is runnable. Well, nothing happens, so okay, great stuff. Great stuff. So let me just chunk this in terms of the YouTube series video archive slash tutorial series. So I'm gonna end this here. It's the basic project setup. I'll just do the next step shortly. All right, for anyone watching the stream, I ended the recording, but I'll restart it shortly. I'll look into questions between the recordings. All right. We're going to continue the tutorial series here since we got our project set up. And we will need some kind of system where we can create a Win32 window. This project here only supports Windows. Yeah, of course, if you wanted to do, well, DirectX 12 is only Windows for now. I heard rumors about it being on Mac as well in the future in combination with Metal, or rather as well as Metal. But yeah, I don't know whether that is true or not. We will do a set of wrappers for Well, I think the uh, preprocessor statement here already sets Windows. So every included header will have the Windows flag as well. So anyway, uh, we will have to create something that can make our application run. We will do a wrapper for this in terms of a class, which we will call an application that you can um, maybe even, or would we like to call it application? Our application here will use our engine. Maybe we want an engine wrapper. Now we will make an application class. Uh, I'll try to initialize DirectX 12 as well. So that's the main goal of the whole tutorial series. I have to go do something in a couple of hours, so we will see how far we get. As mentioned in the description and previous parts of the stream, this stream might be segmented into pieces. The goal is to do an entire setup in terms of um, getting something up and running in DirectX 12. Okay. Oh, let's see. We haven't moved this application here. Let's see. Let's remove all of this. Since we don't need it, we will have our application here, which will use our YouTube API. And this will hold our sort of application stuff, which will handle our Windows stuff. Let's see, we will include this already. And we will also create a namespace in case we want to do something like an application that creates an engine application on the application side of things. That's a lot of application uses, as in meaning the word, but I hope you get the idea. So we will be using these namespaces to kind of make sure that we do not do overlapping classes. As mentioned, this is not a C++ tutorial, but it's good practice. Generally, we want our application to be something that we initialize and that we know is running, and we want to run it in the background. So therefore, our application will have some methods. We will allow it to be default constructed, since we don't care about the actual creation of the application, but we would like a initialization initialize function here. We would also like a flag in terms of a bool to check if the application is running. Yeah, so we will create a initializer function that creates our application. right now in our application layer, we can actually create, and of course we have to use the namespace, so we can using engine, let's see, namespace. Remember only to do this in CPP files, and never in header files. You will enter a world of hurt. And we will call also, this should return a bool because we don't want to do anything in case we didn't succeed in terms of let's just return true if we ever reach the endpoint of this, and then we want to do something like if we succeed in initializing our application, we would probably like to run it, and therefore we would also like a function that is called isRunning, which also returns a bool. We can do this inline since it's not really much code. The compiler would probably inline it anyway, and we will simply return our flag. And we can simply do something like if our engine is running, we do some stuff. This means that we can turn off the application by simply setting the flag to this flag to false. All right, great stuff. We would also like for our application to be doing something while it's running, and we will simply call this method update. So we will do this inside here, and basically we have a sort of a step to initialize a application, check that while it is running, that we update it. But right now, this doesn't do anything. It will probably compile just fine, but we would like to do something in terms of initializing something here. We would like to initialize a window. As you can see, right now our application is actually running, but it's not doing anything. It's just a blank terminal that doesn't do anything. Also, we will be setting up our feature set here, C++ 14. Yeah, I might upgrade it to C++ 20 down the line. But anyway, that doesn't matter too much. We want to create a window. I have a live stream in the YouTube archives from my DirectX 12 game from scratch series, where I go more into detail in terms of the Win32 API. I think that, well, maybe I'll do a couple of quick words in terms of the Win32 API as a part of this tutorial series, since it's a beginner's tutorial. So the Win32 API is a classical Windows API that allows you to, as it is mentioned here, develop desktop and server applications. They can run on all Windows applications. Please note that DirectX 12 only runs on, I think it's compatible with Windows 7, but nothing earlier than that. So that's a restriction. From that. Yeah, so we can create windows with this API in our Windows application here, which is great for us. There are several macros included in our header file. Let's see. We will be using. Let's see. I always prefer to do the library header files here. In this header file, a lot of the Win32 API is declared. Let's see. We will use that and the Windows X header file as well, because it has some. Oh, okay. So it's only Windows 10 and 11. Sorry about that. This has some more macros that we might want to use. We will let the header files decide which of the macros we will use. To create a window, we simply use the create window macro. We need to specify a so-called class name, and it will take a pointer to a literal with the class name, which we will do like this. And let's do a base window class. We will have to give it a name, YouTube engine window, and we need to give it a style. Let's just do overlapped. You can always look at the documentation for different window styles. We want to put it somewhere on the screen in terms of X and Y offsets, and we want to create a screen with a certain size. Let's see, resolution here. Let's do this resolution, and we are allowed to assign it a parent. We won't be doing that. We're allowed to assign it a menu. We won't be doing that. We can assign it to a particular instance. We won't be doing that. And we can pass along a so-called L param. I'll get back to this later on. But oh, I forgot to make it a literal here. So this is basically our method for creating a window. We will refer back to the L param stuff later. So right now we reference, let's see, this also uses the W version of things. And this returns a handle to a window. which means that whenever this is done, we will have a handle to our window, which we can use for different stuff later on. Therefore, we will store that in a variable, and I think it's initialized as a null pointer. Whenever this function returns, which it no, not when it returns, but after the operating system has sent the correct messages to the newly generated window, whatever this is pointing to will be initialized. This means that when this function returns, it will not have a handle ready. The handle will be created afterwards. So when this returns, it will just point to somewhere in memory, and that memory slot will be filled by the operating system after it's done doing some stuff. Be mindful of that. This means that you cannot use this handle here, or rather expect it to be used properly after this function returns. As long as you know that, it's no problem. The pointer will be assigned. It will not be a null pointer in case, except if something fails, but it won't actually be a correct handle. Okay. This means that we can check if the pointer is not valid. And if it's not valid, we will simply return false because we didn't succeed in running our application. Now, we told it that we have a special class that we want to reference, but we haven't nowhere defined that yet. So that means that we have to, let me see, do that. We will use a so-called window class. Struct, which we will initialize as 0. And we have to specify some information. If we look up the Win32 structure here, we get the different member variables. I'm not gonna talk a lot about those. I think I did more in-depth review of these. Sorry, my headset is not great. It sometimes drops out. So yeah, I did a more in-depth discussion of these parameters. I'll briefly go over some of them, but watch the game dev series in terms of creating a window. There's a live stream where I go more into detail available. Okay, we will set the style to null. We will set the let's see, the Windows procedure we will do later. We can set the class name as something of the like of one of the first parameters here. So now we start referencing this class here. This means that whenever we bind this class to the system, this will know what we're referencing. Let's see. We can set up a cursor. Yeah, the Win32 API allows you to load different cursors, even create cursors in resource files. If you ever programmed back in the day, you might remember that Visual Studio had a lot of templates for Win32 applications. It probably still does have, but it came with different resource files. It can also specify an icon. I won't be showing how to set up this because it's also something that you can look up on the internet, and well, I don't find it particularly interesting. If you're doing a game engine series, of course, or rather not series, a game engine, you might want to fiddle around with this eventually. But yeah, we will create a background color here, which takes an H brush, I think. Yeah, it's an H brush, which will simply be our color of our window here. 5, that expands to 5. I'm presuming that this is basic window color style. Next, we need to set up. Well, is there anything else that relates to our style or our actual appearance of our window? Well, no. No. Next, we specify some parameters that relates to the behavior of the window. We will set a we can set the pointer to our menu to 0. We don't specify a menu. In case you had a resource, that would actually be a window, I think. A window inside a window that would provide the control for something like a menu. You could specify a pointer to it, but we're not going to do that. We can also assign a instance. Let's see. Yeah, if we have an overlying instance of our application, we can reference that. We don't have that. And now we're getting into parts where something interesting is about to happen. Because we have specified our appearance, our relations, and our overall naming of our window class, but there are still, excuse me, a few parameters left. There's something called a long pointer to a function called window procedure. And right now we will set it to null pointer because we need to talk a bit more about that. It's basically a callback function that a callback function to a function that handles different operating system messages. For instance, the message from the operating system to create a window inside Windows is actually a message. So, and after processing of several of these messages, the handle will be set when the window is, created. This function has a specific signature that we will return to. Anyway, we can actually store different information inside our struct here. We won't be doing that. These two parameters control exactly that. We won't be doing any of that since it's a way to do yeah. It's a way to make sure that the application has different bytes available that can always be accessed from the operating system or from the message system. And we won't be doing that. Anyway, if we look up the WinProc function in the Win32 API, we see that it's a callback function which you define in your application that processes the messages. And it has the following signature here. Yeah. And it returns an L result. So we need to define something like this. And yeah, we will do that straight away. Let me see. Just it's nice to see that chat helps each other out. I will be doing specific questions at the end of this part of the stream before I end the video clip and do a new recording. Yeah. But yeah, this is a to Z tutorial in terms of setting up DirectX 12 from scratch. We need to do our basic Windows stuff first, though. Yeah. But we will define the callback function. So the signature was something that returned an L result. We would like to be able to tell the compiler that this is a callback function that may have a certain calling convention. So we do that. Let's call this our window procedure. And if we remember correctly, it takes a handle to a window. And it takes a message. It takes a W param. And it takes a L param. Now we can actually provide this function pointer down here. It should always return a value, and if a message doesn't get processed, we always return this call here, which simply handles our messages in the default way. Let's see, does it do anything particular? Okay, it's probably defined somewhere else. Anyway. Okay, the last thing we need to do is actually tell windows that this class is available. We do that with the register class macro with a reference to our window class here. That expands to something that we can't see. Let's compile this. And right now you won't notice, but actually we do create a window. We could Windows does a couple of messages that we can handle. These messages are passed outside our actual window itself. You can look up the first messages of a Win32 window. This is the very first message that we ever get. So we can simply do something like, well, if we get this message, we do something. Yeah. And this will be coming in handy. Let's see. Can we do test? Wait a minute. We can also do like this. No, we can't. Okay. Let's see. I can never recall which header this is defined in. IOStream. Okay. IOStream. It's easier to work with that. See out. Created a window. Okay, we will write that out to our console as a proof of concept, and you can actually see that we created a window. But why is nothing showing? Well, let me tell you. It's because we need to call a show window function where we simply tell whatever handle to do this command. It's probably passing on a message. I don't know the intricate details. And we also want to update our window, meaning that we want to give it a message of whoops, this update window. A message to repaint the window. And there we go. We have a window that really doesn't do anything, but at least it's a window. Let's see, we want to return that, of course. All right, great stuff. We've created a window. I think this will be the part where I end the recording and answer some questions or relate to chat. Because next we will be setting up more stuff related to the application, and we will soon be in a state where we can start setting up the DirectX 12 API. Yeah, but first let me just look through chat. Well, I guess we could do a compiler flag in terms of telling the build system that it's only for Windows. You could do that. If you wanted to. Yeah, Windows X has some more macro definitions that sometimes help out. Just check the door here. All right. I'm unsure what you mean about setting the input files. Oh, and I didn't know you could specify the flag. I'll probably have to divide it into several parts and therefore have to do a later stream with the rest of the tutorial here. So yeah, I think that's going to be the plan. Let's see. Yeah. Do you set it during the style, or do you set it during the flags, or rather the parameters, or where do you specify the flag? Let's see. Okay. Let's just Google it. Create window flags. Win32. Are there any flag? Oh, okay. So it's during the yeah, yeah. So you do a concatenation of flags. Okay. Well, I'll end the offline, or rather, the video recording here. Yeah, check in the next part of this live stream where we do some setup in terms of being able to do DirectX 12 initialization. And let me see. I just need to start uploading the videos. Before I continue, I also might need a bathroom break. So let me see. This is the project setup stuff. We can upload that. There we go. And then also so that's the one. Okay. And I'll upload the other one we just did. Yeah, I uploaded both videos. YouTube is processing them now, so or maybe wait, I did the oh, it doesn't matter. I did the wrong ordering. Yeah. Okay. While that is uploading. All right, while that is uploading, I will continue on this series. So I'll start the next recording. All right, so during our last episode in this live stream / tutorial series on getting set up with DirectX 12, we did our window creation. There are although a few things that we would like to be able to do. We would like to be able to call a method whenever our application window is done being created, because whenever that happens, we will know that our window handle is actually pointing to something, and we will have a valid handle that DirectX 12 can use, and that's important. So we don't want to start up DirectX 12 before we actually have a valid handle. And the way we do that is actually something that I referenced here. You can specify in the last parameter kind of like a something that just gets stored inside the lparam part of the message on the first message here. You can store whatever you like. It's just a bit field. So we could, for instance, store the class reference. This is a pointer to this actual class. Therefore, we can fetch that from the lparam. The Win32 API has something called a create struct on the create call. You can do something like the param, fetch the param inside the appropriate structure. Let's see. Is it specified anywhere? Yeah, so it has a subfield called create parameters. Um, we simply cast this part of the memory as a create struct, so we can access it. And remember, it was part of our L param. And then we know that we store a application pointer, and we simply make sure that we can cast that part of our memory to a pointer here. We will access our create struct and the actual create parameter, and we can then actually store that inside our application / window memory for future use. Right now, you could call things with the pointer here, for instance, update or whatever. But we only have the first message here available. So we can't be sure that our window is actually created. Therefore, we would like to store this information for later. We will set a field inside our window. We will, of course, need the handle to that window, and we will also have to specify the field. And this is where these parameters actually relate to the Windows procedure, because you can specify extra bytes that are available and that you can index with this parameter here. We will just store it in the so-called user data, which is which is a field that you can look up in the documentation if you want to. Yeah. You can see they have different indices. I think custom allocated bytes have positive indices. As you can see, this is intended for the application that created the window, so our use case is actually right on point. So we will do that. And we need to tell it what to store as the last parameter. Yeah, as you can see here, it's the replacement value. So what about just setting this field to our actual pointer? Interpret cast. And we, of course, need to specify the actual type here. And we will store our pointer. This means that the very first time we send a message to this Windows procedure, we store the parameter that we passed along here, which is a pointer to the calling class that gets stored in that particular Windows application setting database or whatever. This means that now we can access it, and we will do that when we actually create our window. and we will fetch the application pointer by casting the specified memory to a application pointer, and we will get our window long pointer. It's basically the get version of the set version, and we will just have to specify our handle and then where to access the data. This means that you could store more elaborate structs if you wanted to. I don't know how large the register, or rather not register, the memory location actually is. Yeah, but you could do that if you needed more information stored in the application. So now when we create um, our application and we know our window is created, we would like something called onCreate that we can call with our pointer. There we go. And let's just do something. Oh, not a vector. Created the actual window. And there we go. Our console created. Let's create it. Send create message. And we created the window. We don't need exclamation points. Yeah. So this basically means that now whenever we enter this function, we are certain that the create message has been sent, and our window is created. Create window, return handle, and just to show you that I'm not just making things up. As you can see, this is, oh, I got it the wrong way around. So we get this message after the window is actually created, but before it becomes visible. So we can be certain that our handle is intact as early as when we get this message. But I didn't realize that whenever this returns, it actually is done sending these messages. Anyway, the whole thing about initializing the thing in the correct order is correct anyway. But we would like to be able to pass along our handle so we will pass that along since we will need it for our DirectX API. Okay. We're mostly done with the basic stuff. Mostly done. No, we still need to do some message handling. in terms of message processing for later messages, so that our window can become responsive. So we will do that. Here we will grab all messages from both the operating system, but especially the messages that get sent inside our application. We will grab peek into the messages as long as this function actually returns that it's doing message processing. It will return true. We don't need to specify a particular handle. We don't need to look into a particular part of the message stream, and we want to remove the message from the queue whenever we're done with it. And you do some method calls here in the Win32 API where you translate the message and you dispatch it. And now our application should become responsive. Right before we did this, let's see if we don't do this. I think now at least right now I'm trying to drag the window as before. It doesn't register any messages, but since this message handling got implemented, it does actually process messages. Right now, as you can see, it just is unresponsive. The messages can't be processed. If we peek them, we remove them from the queue. If not, they just accumulate in the message queue. This is also part of the actual application messages. These are potentially operating system messages that could be sent outside the application to the application. Just bear that in mind. All this relates to, excuse me, to the actual application itself. So whenever I drag the window, resize the window, minimize the window, it's the message. It's a message that gets sent to the actual application. It's not sent through the operating system. The closing of the actual application is an operating system message. It's called WM destroy. And if we ever get into that state, we want to do some stuff. Let's do an on destroy here method that we will couple with setting our is running flag to false. So whenever this gets called, we will make sure that the rest of the program knows that we are not running anymore. And we will also send a message that doesn't contain any errors. 0 is fine. And now you should see that I will be able to click the close button, and even the console here stops running. shutting down. I can see we missed the end line up here. Anyway, we have now coupled our message handling to our application. You could do all kinds of stuff with that. You could do custom message processing. For instance, if you drag the window, maybe you want to pause the application and set a pause flag somewhere. You could do resizing. You could do a lot of different stuff. Yeah, I need a bathroom break. So this means that I will be ending the recording for the video series on YouTube. Yeah, but I will continue shortly, where we will dive into the basic setup of DirectX 12. Yeah. Yeah, here on stream, I'll of course continue after the break, as well as do a new recording. Let's see, let me just upload the old one. Yeah, I'll be right back. Let's see. All right. So your LP create struct doesn't work. Did you pass along the class pointer? And have you been able to get a window on the screen? Did you do these function calls? Or this one? Sorry. Okay, does it work now? Malformed error, did you get it working? Because I'm about to continue. And inside here, you do everything. There's no window. Yeah, you need to set the Windows procedure. And you of course need to set the is running flag to true and return true here. Did you get it working? Yeah. Did you put this in your Windows procedure? Does it, if you do something like this, um, print this out to the console, does it actually print that? Uh, oh, that's maybe, oh, you should probably remove that. It tells the system that you are not creating a console application. Yeah, but we're doing a console application that does. Yeah, that's because you can't. Yeah, you should do a console application instead. You shouldn't do a Windows application. The function pointers for the main method are different during the runtime. Yeah, I'll give you a couple of minutes to change it, and then I'll probably have to continue on. I'll just edit the YouTube stuff here. I don't think I need that one. Uh, uh, Um, I can create a repo really quick, and you can download this repo. Uh, uh, okay, I'm running into trouble in terms of setting up the. Mm, yeah, I need to tinker around with GitHub in terms of creating the repo. Um, yeah, I think you probably diverged a bit somewhere, and that I'm thinking that it's probably related to the project setup. Because I'm suspecting that you create an instance when you do a subsystem Windows instead. Um, and you may set up the header files for compilation in that type of setup, but or rather environment, but I'm not sure. But yeah, you should be fairly quick at catching up, even if we move on. I mean, you can just redo your project as I did, and and copy your code over. Oh, okay. Everything works then. It shows a window. Let me see if it's related to the Windows X header. I don't think it is, but no. Does your code match this? Yeah, I think it might still relate to your way of building things, because if you build things as a Win32 application, yeah, if you build things like a Win32 application, you're basically doing this in some way twice, or at least this part of there might be overlapping structures, because a Win32 with the declaration of subsystems Windows is set up to actually create a Win32 application. So you might have problems with the instance of the process, and yeah, since we don't have a initialized Win32 application at all when we do a console project, um, um, uh, we know that we don't overlap with any other process in the operating system. So if you can't get it to work this way, go back to creating the project as I've done it. Um, I don't know if you're coding along, Mr. Yes, are you? Yeah, yeah, yeah. For some reason, your window doesn't get created. You may have wrong parameters here, or you may have trouble in terms of the way that you set up your project. Um, this function here allows you to specify an application instance. Maybe you need to do that with your current project setup. Uh, let's see, Win32 window instance subsystem Windows register create window. Yeah, I think this. Uh, yeah, you probably inside your WinMain API call need to pass along the H instance stuff. Yeah, exactly. It's because you chose to do a different approach. Uh, a Win32 application always has a process, and you need to reference that to be able to create windows on that process. So, yeah. Oh, something else changed? It wasn't related to the instance stuff? Could you elaborate on what the error was so that we know for sure? Oh, okay. Turns out your code wasn't as mine. Okay, in order not to delay things too much, whenever you decide to do something else, I can't promise I can help you debug it. It takes a long time to figure out what someone has done in terms of code alteration. So yeah. Anyway, let's continue. I'll start the recording. Uh, we will continue the series. In this part, we will start setting up some different um, DirectX related API calls. Uh, um, Again, I've done more elaborate discussions of the different parts of the API. Um, in my streaming series, I had a lot of problems during the early phases of the streaming series, so there might be problems with the audio or problems with a missing video here and there. So I'll try to not dive too deep into the API stuff uh, in terms of what we actually do, but yeah, try to focus more on actually getting something up and running. So the general way I structure these things is that I do a um, separate renderer API. Maybe we do something like this in our engine. Um, we will do a subfolder called DirectX 12 because what do you know, maybe you want to um, actually do other APIs as well. So we will do a folder structure like that. We will create a new class called render API. Which we will put inside our folder here. And we will, of course, need to use the YouTube API call here. Let's include the engine minimum file for that. Inside our application here, let's do like this. Maybe we actually want this first. And we would like to include the render API because this application will have a render API. Let's do variables and subsystems. And let's do a render API. And we will instantiate one of those. We will, of course, need our namespace. Let's see. We also need to add maybe an include folder here. We want to include our project directory source to all our files. There we go. So we can always reference our root as our root. Otherwise, it will just try to access at the project directory. We don't need to do this anymore. Okay. And everything should still compile. Yeah, everything's great. So we do a namespace here. I'm really used to typing GXE from the other part of my live stream series. We will allow a default constructor. We will definitely have a destructor that we will implement, and we will have a let's see. We will have a initialize function that will take a handle to our window. We will just create definitions for these. And in our application, when we do our onCreate, we access the renderer and initialize it with our handle to our window. So now when our application has created a window, we will always initialize our renderer API. So this means that we can actually start initializing some DirectX components. DirectX 12 is a really low-level API. And the idea is that you want to access the hardware. Then you want to sort of create a virtual device which is kind of like the context for the D12 API. And then you can start creating other elements on that context. So the DirectX API is an API that builds certain components as long as something keeps the reference to that object alive. It keeps staying alive for as long as it's referenced. It's based around the old COM system where you have different hardware-related systems that are encapsulated in an API that is reference counted. It means that as long as something is using the particular part of the API, it will never go out of scope, and therefore the resources will never disappear. But yeah, what we need to be able to access the hardware is actually, excuse me, something called a factory. And we would also like to be able to access our API, of course, but yeah, let's do that in our PCH file. We will include some DirectX headers. We will include DirectX, let's see, the 3D12 as our header, and we will include the DXGI version 6. These are some headers that we need. They come with specific lib files that are pre-compiled. These are just declarations, and we need to make sure that we actually include those during our build process. In order to be able to actually access access the function calls. So we need to also include those. We will do this as a preprocessor declaration where the system simply gets told, well, I want to include this library, and I also want to include this library. I'm not sure it cares about caps. So imagine like what we're doing here. If we only did header files and no CPP files, no actual function definitions would be available for our program to call. It would only know sort of where to look up the actual declaration, but not where to call the function, and the function itself would not be compiled with our application without these includes. So we include those. We need to create a factory, and it happens to be a part of the DXGI part of the DirectX API. The DXGI is basically a part of the API that provides an infrastructure. It's short for Microsoft DirectX Graphics Infrastructure that handles different parts of um, the layered um, uh, instructions for the kernel and the system hardware. This is important because as it states here, you could just do it directly, but maybe you want some control over which kind of hardware you're using for your application. These days, GPUs are integrated inside our CPUs, and you may have a dedicated CPU, you may not. And you probably want to be able to look up specific hardware specifications for your application and check if they are sufficient to run your application. So therefore, we will do a DXGI layer in our application. And a DXGI layer always starts with a DXGI factory. And we will, of course, create a namespace here. Would we like to? No, we don't care about subdividing this namespace into DirectX. We won't care about that. Let's do a default constructor because we can create an factory without doing anything with it. Oh no, maybe we don't want ever to create a actual empty factory. Okay, but one last thing. Since in order to keep this factory alive as long as we need to make sure that it's reference counted. Remember what I said in terms of the API, only keeping different pointers active as long as the reference count to an object is higher than 0. Microsoft provides a structure that handles reference counting for us, which is pretty nice. And it's a so-called scoped structure. It's a resource allocation is instantiation based structure of sorts. Well, I'm not sure that it lives up to all those requirements, but anyway, it's a really handy structure because it means that whenever we use that structure to create a DXGI factory, whenever that thing goes out of scope, we make sure that the reference counts is reduced. And the thing that we use for that is called the com pointer. And it's actually declared in the WRL header file. You could do core if you wanted to, but it's inside the Microsoft namespace, the WRL namespace, and it's a com pointer. So if we make this class inherit from that com pointer wrapping an actual DXGI factory, we simply make sure that whenever we create this, it is actually a pointer that is reference counts to this actual object inside the DXGI API. You might ask, why does it get named IDXGI? It's because the I means interface. It's basically a pointer to somewhere in the API that has a specific API calls attached to it. In order to allow us to do debugging mode, we actually need a DXGI factory version 2. You can always Google that, but let's see, factory debug. So as you can see here, the factory number 2 there are different functions related to different interfaces, but you can look up what methods are new or rather available in that particular interface. Okay. But yeah, there's a lot of reading in the documentation. I won't be expanding too much on what I've learned from the actual documentation itself about the API behind. Let's see, did we do? Okay. Well, at least I have experience with the getting debug information from the actual factory is problematic without creating a factory version 2 at the minimum. So we will do that. Okay. Inside our application, whenever we create this, we will create the DXGI factory called the create DXGI factory 2. It will allow us to pass in flags, and then it needs to get a set of information here. It needs a specific interface ID reference where it can store the interface ID, and it also needs a place to store the actual pointer to the created factory. There's a macro that allows you to handle that is called IID PPV, which actually matches this signature. First it takes the IID and then the pointer to whatever value we need, and we simply only need to store a or give it a pointer. Since this one is inheriting from the com pointer itself, the com pointer has a member variable that is stored in here. It's an interface type. So that means that if we simply pass it that pointer as the void pointer, as long as that also contains our interface type, we make sure that the ID and the PPV actually are the correct values. Sorry. This method returns an H result. It will return the message OK if it's sorry, if it's succeeded, and it will return some error code if not. Let's create a header file here where we will create some helper functions that let's see. Let's do these afterwards, where we parse the result. So let's create a wrapper as a macro. YouTube evaluate H result, and we pass in our H result and then our error message. And let's move the IO stream here into our PCH file. I also think that we would actually, yeah, I never know how the include stuff gets handled, so I don't trust that Visual Studio doesn't complain if I don't specify those headers. Anyway, if the H result is unlike is okay, and let's parenthesize this in case we end up in a weird situation with an expression of sorts. Maybe we do some bit manipulation or whatever. If this is the case, we will simply call our cout function and output something to the console. Let's see. API error, and we simply pass in the error. You could do more elaborate parsing. For instance, you could add a file name or some of the file name macros. Maybe file name macro. No. We will. We are just writing our own failed macro. Yeah. let's see. I think add file. And we do the inline function call here. Let's see, did I write out everything correctly? It seems that I did. So now we do the YouTube evaluate each result, and we some error. We will of course need to actually instantiate our class here. So we will create the factory right here, DXGI factory as soon as we initialize. So let's see, does it succeed? It succeeds. To test out our macro, we will simply just temporarily do this. It will here you can see it will dump this error, some error at file, blah, blah, blah. And you will know which file it actually occurred in. But of course, we don't want to do that. I think that this is better debug information than the standard failed macro. You could do even more H result parsing in here. You could do different error codes for different H results. Yeah, you could do whatever you'd like in terms of getting more information about the error code. But yeah, there is one flag that that we would like. So this is why I use the factory 2. It's because we can request that the system loads the debug DDL, which is nice for our DXGI debugging. So we will actually use that flag. Right now, I think we need to, we should probably include the library as well, or the .lib file. No, maybe we don't need to do that. Maybe, oh, maybe we do. Let's see. There's a DXGI debug header that we will use in the future. And I think that it also comes with a lib file for its method calls. So I think the DXG, okay, that is weird. I think this is correct though. Yeah, everything still compiles. All right. So actually now we have created our factory. But what, excuse me, what would we like to do with our factory? We have now created something that we can use to access hardware components at the very low level. As you can see, let's see, was it referenced here? No, it wasn't. DXGI. Where was it? DXGI interface. Anyway, you saw the diagram before about being able to access different components. Okay. So we would like to access some hardware here. We would like to get what is called an adapter. It represents a display subsystem, including one or more GPUs or DACs, and some video memory. Excuse me. Which sounds like exactly what we need. And the DXGI device is actually a derived class. Let's see. But I don't think we will use the device itself. We will use the DirectX 12 version of the device. It's probably related to each other. Anyway, we would like to be able to get an adapter and store that in a COM pointer wrapper. So let's do that. Let's create a DXGI adapter. Hopefully everything is visible on the stream in terms of where I move things. Yeah, it seems like it. So yeah, we will create an adapter. As before, we will create it in our namespace here. We will include our COM pointer. We will make this inherit from the COM pointer class. Oh, I forgot the namespacing. And remember, never use the using namespace stuff in a header file. There we go. And the interface is ID GI, XGI adapter. I don't know which version we want. Let's see, do we have any specific feature set for any of them? I actually think that, whoops, we're fine doing whatever, some more memory residency methods, so we can reserve physical memory with more advanced adapters. Some extra functionality. I'm pretty sure that this is sufficient. Yeah. But you might want to explore different versions. What can this do? It gets an updated description of the adapter. I don't know what the description holds that it didn't. Yeah. Since DirectX 12 is Windows 10 and up, you could do adapters that kind of like suits that. You can see we can use methods on the number 3 version of the adapter to ask about different memory usage aspects, but yeah, I've never really used that. Maybe your application has needs where it needs to Give you information about how the hardware is used. Maybe you want to try to reserve certain amounts of resources on the device for your application to test out constraints. What do you know? There are a lot of different possibilities. Anyway, we will be creating a adapter, and we will be allowed to create a empty adapter. We can also create an adapter with a specific pointer. This will be smart if we, via some other method, decide to create an adapter, and we want to store the information inside of this. Let's see. We want the namespace here as well. I hate this kind of layout here. And we will simply instantiate the member variable. Component ID DXGI, or rather I DXGI adapter, where we pass along the adapter here. So if we instantiate it, we store the pointer to the actual adapter. Inside this compointer object, it also has a constructor itself where it simply assigns the pointer to the internal structure. So that's pretty neat. I'm sorry, I'm starting to develop a cough. All right, then we would like our factory actually to be able to grab our adapter and store it. So we will include our newly created DXGI wrapper, DXGI adapter wrapper, and we will get an adapter. Okay, I forgot the namespace here as well. Let's move this. There we go. It's inaccessible. Oh, we forgot, of course, to make these public. Yeah. So now we can call our factory and start grabbing some information about our adapter. The problem is that we might want to do some checking for the kind of adapter that we want to use. As I've mentioned before, we might be in a situation where we have multiple GPUs, and how do we select the correct hardware to use in our application? as you can see here, this type of factory enables a method that allows us to enumerate our graphics adapters based on a given GPU preference. We can actually look up this function call. We can pass it a type here where we try to select something in terms of the minimum power usage or the highest performance. As you can see here, this usually selects the integrated GPUs if you choose the minimum power version, and this kind of tries to force a sort of adapter that has a discrete GPU and that is performant. We want for this application to be able to grab whatever is our most performant application. So therefore we like to be able to in this file I will be using the namespace Microsoft WRL. We will be creating a COM pointer to our DXGI factory number 6 here. And we can simply ask our what do you call it, current factory if we're allowed to use this interface with the existing interface. The DirectX API has a method for that. Let's see, DXGI. Doesn't it? Let's see, and let's do factory. It inherits from the DXGI object, which has IOnknown as an interface. Enables the client to get pointers to other interfaces on a given object through the query interface. So we can actually ask if we support this functionality. Sure thing, buddy. I will also be ending this part of the live stream in maybe 40 minutes or something, maybe a half an hour. So we will have to continue on later on. Yeah, but this means that we can actually query whether our whether we can get a pointer for the specific interface. Meaning that if our DXGI factory supports the factory 6 interface, we can temporarily use those interface features as long as we store them somewhere if we want to access them. Let's see. Do we have a return type? yeah, returns SOK. Okay. We also want to return a ID XGI adapter whenever we find the correct adapter. Every COM pointer has the get method, which gets the underlying interface of the stored in the COM pointer. It's basically this pointer here that it accesses, and you can call query interface on that interface. It's almost like I'm doing a lot of word salad. As you can see, we can use the ID PPV args helper macro to check for the actual interface ID and point to a place to store it. So we do that, arg, and we want to store it in our the address of our FAC6. And we know that this returns the SOK. So if this succeeds, we are allowed to use the factory 6 interface, and it will be stored in the factory 6 interface. We can now query for the most important device. We can use our YouTube evaluate result here in terms of accessing our factory 6 and enumerate the GPU adapter by preference, and we want to select the first adapter on the list. Let's look up this method so it makes sense. The index of the adapter to enumerate. So we want the first high performance GPU, and we want to store that in a pointer somewhere, and we simply pass it our adapter variable here. And let's see, error finding the adapter. There we go. And lastly, we get our underlying pointer from our adapter and instantiate this. So now inside our renderer, we can actually do something like this. We can do a DXGI adapter, which we get like this. And now we have an adapter. And nothing fails. So we now have fetched our hardware. We really don't know it, but it does happen because we could also do something like we could do another helper maybe we want to include exceptions here. And we could do a YouTube assert. You wouldn't want this in production code. You would, maybe we already gonna do that, not in the application, in the engine here. Our preprocessor debug mode is actually like this. So if def otherwise, so if we're in debug mode, we want a certain way of doing things. If the expression is not true, we would like to throw an error. We can do something like std cout critical error in file, and then throw an exception. Hello Karim, yes, it's from scratch. I also do uploads on YouTube in the video section where you can basically follow along from A to Z. I cut out parts with breaks. So during debug mode, we should compile this one. Let's see, does everything compile? And you only missed out on the adapter creation here. So for instance, if this doesn't succeed, we would like to assert something, YouTube assert, and we will simply do false here. You could again do more elaborate function calls. Let's just see that everything works. If this actually works, we will assert, yeah, and we will get a critical error in file, blah, blah, blah. Okay, let's just change this back. Okay, so now we have our adapter. It's enumerated by the highest performance. You could do more elaborate error handling here. If you, for instance, wanted to get a message if the application couldn't find any adapters or whatever. But since this is not a programming tutorial per se, but a DirectX tutorial, we won't be doing something more elaborate. And it's up to you to do whatever implementation and experimentation with the different interfaces in terms of building out functionality in your application. Yeah, so so far our renderer is able to create a factory and use that factory to fetch the most performant adapter. So we don't get an integrated GPU instead. We could do that. I don't think I have mine connected to my screen. Let's see. If we access our adapter here and get the description, we can actually get the adapter description. Let's just use that for fun. Adapter description. Let's see the let's see. Okay. Let's see. Oops. It doesn't like that. Oh, I did the same thing, I guess. Wait a minute. Yeah, that's exactly it. Let's see. Have we missed a public somewhere? Oh, wait a minute. The underlying interface is not public. Oh, we need to do that. Of course. Otherwise, we can't access it. Now everything should be fine. And we want to store that inside our description here. And we want to access that. Let's see what field. The description. Yeah, the adapter, since we're using the DXGI interfaces, we're handling specific hardware. As you saw inside, yeah, there was some documentation on, yeah, the DXGI Factory 6 supports enumeration of adapters in terms of a certain GPU preference. Right now, I just wanted to show you different effects of this process here. So let's see, what was the description here. We will also create a macro for that. Okay. The description is portrayed like that. Because the factory 2 doesn't support enumeration accordingly to different parameters. So we query if we can use our current factory to temporarily reference a factory 6, and we use that temporary interface to enumerate here. No, I won't be doing Vulkan. So let's see if we did like this, we get this description here. And if I do like minimum power, do I get another value here? I do. As you can see here, these two values are different, which means that my system grabs different GPUs in terms of query interface is a fundamental call to every API interface in DirectX and DXGI, where you ask the current interface you have if it supports a certain interface. So here, this line here asks our factory 2 whether it supports the factory 6. If it does, it assigns it to this pointer here, and if it does, it returns the H result as okay. So as you can see here, this this here means that I actually get two different GPUs in terms of what flag I specify here. So yeah, it definitely does something. I don't know how to pass the description in terms of the output value. Anyway, I don't know. Maybe it's cout handle vchar. Oh, okay. If we actually changed it to maybe, yeah, okay. As you can see here, I'll get an NVIDIA GeForce RTX 2060. It was just me that didn't know my chart parsing here. And if we do like this, I get some integrated Radeon chip. Okay. We will actually keep this. One thing I'll do though is create a small helper here where we define print W and new line and the message, and we simply WC out the message and the end it with a new line. We will also define a regular print so I don't have to type the same thing over and over. Okay. So now inside our renderer, we can simply do print wn selected device. There we go. And we're golden. Okay. The last thing I will be able to do during this part of the stream will be probably initializing some sort of device, which is a virtual device that DirectX 12 uses for everything, or basically everything. It's not part of the DXGI pipeline. It is part of the DirectX 12, not pipeline, interfaces, of course. And we will maybe call it base. We will be creating a D12 device. Excuse me. And we will, of course, do our namespace here. We will do the same thing inside the CPP file so that I don't go insane. And we will include our WRL. And this is basically done as the same thing as all other interfaces in terms of either DirectX 12 or the DXGI. But yeah, the naming is somewhat different. You have to create an interface that is prefaced by the D3D12 D12 device. Let's see, I need to type it correctly. And yeah, let's see, our previous files here didn't bother whining that we haven't included these, so maybe the precompiled header works. If you ever run into trouble with these things, just know that you might have to include these header files here in your separate files. It depends on how the compilation is done. Usually it's really good at doing the PCH file first, which means that everything is defined, but sometimes IntelliSense or the build order might screw you over a bit. So yeah, but we will be creating a device. We don't mind being able to create an empty device. If I recall correctly, let's see, yeah. It's nice to be able to create an empty device because I usually store it, which means that we store the com pointer to the interface, which is a few bytes, on the actual renderer. Because we use the device for so many things. We would also be like to be able to create a device on a specific adapter. And we would also like to, in case we create an empty device, we would also like to be able to initialize it later on with a certain we will create these methods here. Brilliant. And the explicit constructor here will, of course, just call the initialization method right after construction. Okay, to create a device, we need to find the appropriate method. This is the method. We need to pass in the adapter. We can always use the default adapter, but since we are creating a performance critical application, we want to have control over which adapter, which is why we ran through the whole DXGI thing. We also need to determine a so-called feature level, and of course we need to store it somewhere. So let's just specify the minimum feature level as a start, and then I will do a short explanation of these feature levels. But as you can see, it also returns an H result, which means that we can simply wrap it in our evaluate H result function. We create, well, it was interface 3D 12 create device, right? Yeah, it was. And we want to pass it our adapter. We want to pass it our feature level, and we of course want to store it. We need a pointer to a pointer to a device. And earlier we did like this, which is fine because the address of this pointer is a pointer to a pointer. We can do that again. We can also do the get address of this com pointer, which will be the pointer to the pointer. Yeah, you can do whatever you want. Both is fine. Both are fine. Error creating device. There we go. So this is basically it. As you can see, we're creating small wrappers for a lot of the interfaces. You could always apply more logic to all of these steps if you want error handling, if you want something else entirely. The whole idea behind them is that you can instantiate empty quote-unquote classes by using a default constructor, and you can later on initialize the contents of this com pointer, which means that you can store this on other classes, no problem, and don't have to bother with instantiation and everything. And you can access the components, and also the com pointer itself. Make sure that whenever this goes out of scope, was to make sure that the reference count goes down whenever the wrapper goes out of scope. All right, so in our render API, we would like to include our newly created device here and store it. So let's do a D12 device and device. I actually think we could instantiate it as a null pointer, but it doesn't matter. And let's see, we call this init function here inside our initialization step. We do initialization of our device. Let's see. Let's initialize it with our adapter here. We simply get the underlying pointer from the com pointer, and we store our device. You could do error checking of this is critical to our application. So maybe you want the init function to return a bool. Uh, maybe you want something else entirely, but yeah, you definitely don't want to proceed if you can't create a virtual device, because you can't do any DirectX calls without that. So this is our basic setup. Maybe we can do something in terms of our device here. Yeah, we can do lots of stuff, but can we get anything interesting? Get private data, what does that do? We can set our stable power state. Well, okay. We can set our name here. Main virtual device. All right. I think that will be it. Um, let's see. Okay. Undeclared identifier. Well, we need to include it, of course. There we go. Only we would like. Well, we should have included that. Okay, it's referencing the interface here. Yeah, okay. So the device, for some reason here, wants us to include the header files I mentioned before. So yeah, if you run into that, it's just a matter of selecting that header file and dropping it inside the device declaration. Sometimes it's rather random which order these header files get compiled in, at least so it seems. Maybe there is some intricate way of forcing the compiler to do it in a specific order, but I'm not gonna bother. I'm just gonna make sure that the compiler is satisfied. All right, we will compile this and then I'll just do some basic testing. Maybe we can use NVIDIA Insight here. New project, YouTube tutorial. I will get back to this application here in another part of this stream series. Let's see. Let's try launching this. Let's see. So it has no process, but it actually launches the application. Okay, I can't see any information yet. Maybe render docs allow me to do something. Render doc allow me to do something. Maybe not. Let's try that. Let's see. Well, there's no process yet, so it can't do anything. But let's see, reference, all resources. Let's try that. Resource inspector. No, it doesn't consider the device as a actual resource. Anyway, I promised the feature level here. I also did a bit on that during the other live streaming series. We will want to change this feature level since the core feature level is pretty low. Let's see. DirectX 12 feature level wiki. Feature levels in DirectX 3D. So these are DirectX 10 and 11 feature levels. As you can see here, we actually get the different feature level specifiers. Then we get into DirectX 12 feature level territory. They overlap, of course, and you can see that different hardware supports different feature levels. And different shader models. Okay, core is basically a compute only, it seems. So we're definitely switching that. DirectX 12 Ultimate is included in Windows 11, so if you're running that, you will have access to that. People running Windows 10 will only have access to the feature level 12.1. I don't think it will crash or whine if we try to fetch the feature level that is higher, but we'll see. Okay, it will actually crash. Error creating the device. Well, great stuff. My GPU does support it, but it's probably related to us not having the DirectX 12 Ultimate enabled. As I've mentioned, you need to run Windows 12 for that. Let's see, does it accept this feature level? Well, it does. So now we have the maximum available feature level, which is available to me in Windows 10. And yeah, you can always look into what these different things mean in terms of shader models and different stuff like that. Just look up the wiki here. Since I need to go shortly, I will be rounding off the stream. I will be answering some quick questions and then I will be on, and I'll of course upload this video to the video archives very shortly. So yeah, so far during this live stream, we've managed to set up a project with a separate DLL and a application that uses that DLL. Inside that application, we create a window. We couple that window to our renderer API, and our renderer API starts initializing DXGI components, starting with the factory, which is a way of fetching the underlying hardware. Since the factory version 2 supports a debug factory flag where you can get debug information about the hardware states of your different components. We chose version 2, but since the factory version 6 supports enumeration of your hardware in terms of different parameters, we use that interface temporarily on our factory 2 interface, and we use that to find the most powerful GPU in this case, and we use that hardware what do you call it, piece of hardware to create a DirectX 12 virtual device, which is sort of the overlying context on which different API calls, excuse me, from DirectX 12 will come through or go through in terms of creating different resources, handling different calls, and so forth. In terms of the scope of the live streaming series, I don't know when I will get to where, but I'll definitely end up sometime or another at a point where we will be able to render something to the screen. We will also use RenderDoc or NVIDIA Insight along the way to kind of like show how you can verify your application is running as intended. Well, the physical device, the device is actually a piece of software API that reference the physical device in terms of the underlying adapter. Yeah, I think I have time for one more question, and yeah, it's basically the same. It's just a macro. I find that the IID PPV args macro is way faster to type, and it always makes sure that everything is cast to the right types and so forth. So yeah, I prefer that one, but you can of course use the UUID of the particular interface you want to query. It doesn't matter. They're basically the same. This is just way faster to type. Well, thank you. Thank you for tuning into the stream, and good luck doing all your projects. If anyone found any of this helpful, feel free to comment, like, or subscribe, or even follow on Twitch. I'll catch you around sometime in the future, where I'll continue on this series and the other series on the channel. All right, take care. Bye bye.